Follow me on tooltech.com, where I try and keep people up to date about my latest activities, including all of my YouTube videos. In this course, we're going to explore the types of service we have available in Azure, then dive into some details on the type of compute services available in Azure, thinking about automating those services from a provisioning perspective, both the Azure Resource Manager resource, and then maybe even what's inside it, for example, a guest operating system. And then double clicking on containers, thinking about container services in Azure and container orchestration. For this module, we're going to explore in detail those different types of Azure service we always hear about, those Azure Compute services that are examples of the different types of service, and then thinking about that provisioning. Now, why is this so important? And it really comes down to the fact that ultimately, we typically want to do something in the cloud. We don't really care about the particular services, but understanding the different types of compute that are available in the cloud and the various features ensures we pick the right solution to both minimize our overhead, i.e. we're not reinventing the wheel, we're not maintaining things we don't want to maintain like an operating system, but also optimize our cost. Let's pay for just what we need. Could I run everything in a VM? Absolutely. But then I'm responsible for all of the different layers, and it may not be the best solution depending on the type of workload. So we need to understand what's available and when to use them. In this lesson, I wanted to explore the types of service available in Azure. But we can first start thinking about, well, what even is Azure? It really boils down to the fact that Azure is really capacity. On premises, we have capacity. We have servers with compute. We might have SANs with storage. We have networking. So overall, we have capacity. And then we do something with that capacity. Now in Azure, that capacity is globally distributed. We think about logical groupings within a latency envelope, which are regions. It's a multi-tenant model. It's consumption-based. And what we really have is that capacity is exposed to us as services. And there are various types of service available. We think about virtual machines, app services, even serverless. Behind the scenes, these services are using various aspects of the capacity, be it compute, storage, networking, often a combination. But that's really what the cloud is. It's capacity exposed through services. Now, what are those common types of cloud service? And it's really good to think about layers. Now, on premises, I'm responsible for everything as the customer. I manage everything, the networking, the storage, the servers themselves, i.e. the compute. Then I have a hypervisor, the virtualization layer. Then I create virtual machines. I have an operating system I have to patch, back up, make sure it's highly available. Think about antivirus, firewall configuration, and much more. I have various middlewares and runtimes installed that I have to maintain as well. Then finally I get to the bit I really care about, which is my application and my data. So I have to have teams responsible for everything. When I move to the cloud, the first type of service we see is infrastructure as a service, basically a VM in the cloud. Here, the vendor, in this case Azure, they are managing the fabric. The compute, the storage, the networking, those physical elements are invisible to us. The hypervisor, which is Hyper-V under the covers for 99.999% of the services, is invisible to us. What we get at that base level is a virtual machine. Now inside that virtual machine, I'm king. I get to pick the operating system, Windows, Linux, different versions, but I'm also responsible. I have to think about backing it up, that antivirus, that high availability, that configuration. Now, there are things in Azure to help. There are extensions. These can hook into other Azure services to help perform all of those tasks, but I'm still responsible for making sure I get those in place. Then I might install various middlewares and runtimes that are required to once again get to what we care about, our application and our data. Now, this is a good fit maybe for lift and shift. Hey, I have an existing application, I just need to move it and run it in the cloud. Then we get to really the goal is platform as a service. Here I just focus on my app. I have my application and I want to deploy it and run it. I don't really care about an operating system and all of the management. I don't care about patching runtimes or middlewares. I just want to run my app. That's what brings business value to me. So platform as a service allows me to have that laser focus. I just care about my app and my data. The platform is doing everything else for me. So if I'm writing my own custom app today, I want to try and use a platform as a service offering to minimize what I'm responsible for, i.e. minimizing what I care about. And it's also software as a service. Think about something like Office 365 or Dynamics 365, Power Platform, etc. I'm not responsible for anything. I don't manage anything. I'm not patching an application like SharePoint or Exchange. I'm not backing up my mailboxes. I might do some basic administration. Hey, I enable this user for that service, but I'm not actually managing that application. It's all done for me. Often it's evergreen. It's constantly being updated. So if I have a business requirement and I can solve it with a SaaS solution, that's going to be my go-to. If I don't even have to worry about creating a custom app, if there's some SaaS offering that does what I need, great. I can really focus on my business value. The point is you have choice. I can even have on-premises with Azure with services like Azure Arc or Azure Stack offerings. But then we can move through, hey, VMs in the cloud, platform as a service, even SaaS. In this lesson, I wanted to quickly review the compute options we're going to focus on over the next few lessons. Firstly, we have virtual machines, what we think about as infrastructure as a service. Then we have virtual machine scale sets, multiple virtual machines provisioned via a single configuration based on a certain template, image, and configuration, useful for when we have many instances that are all identical. This gives us features such as auto scale, so we can respond based on demand. Then we have containers. Containers is really everywhere in Azure today. So we're going to explore the container services, including things like Azure Container Instances, i.e. container as a service. Containers need orchestration, so there's Azure Kubernetes service. And both containers and AKS are actually the bigger focus of the next module. Then we have Service Fabric. This actually powers a large part of Azure and was an orchestrator for various reliable actors and services before we even thought about containers in Azure. And there's the Azure App Service. I can take my web-based application, my mobile app, my API app, and just run it, not worrying about any underlying infrastructure. And then the various serverless offerings, Azure Functions and Logic Apps. In this lesson, I want to cover virtual machines. Now, as the layers show, here you're responsible for everything from the operating system running inside the VM and above. Now, I can create a virtual machine from a variety of series and sizes. Now, these have different capabilities. If I think about my requirements, often I'll have some workloads that are more compute focused. Some I have a bigger skew towards memory. Some might need extra storage capabilities. Some might need special types of hardware like GPUs. So the different series of virtual machines are optimized about different types of resource. If I jump over to the sizes page, I can see, well, there's VMs that are more general purpose, ones that are compute optimized, ones that are memory optimized, ones that are storage optimized, and ones that are GPU accelerated NVIDIA CUDA cards. And then we have high performance computing with very high performant networking connectivity. So there's all these different series based around different optimizations of the types of resource. And then within these, we have sizes. So I can think about for any particular type of these, I could go, for example, to the EV3, and I'll see there's different sizes in E2, E4, E8 that have a proportionally increasing number of virtual CPUs, memory, temporary storage, storage throughput in terms of IOPS and megabytes per second, even network adapters and network throughput. So we have all these different types of characteristics that as the VM gets bigger, well, we get a correspondingly bigger portion of the underlying host resource. So I would find the series that best matches my particular requirements, be it compute, memory, network, storage, specialized hardware requirements, and then the size to meet my exact needs. Now, while I'm talking about virtual machines, those sizes and series we just saw power a huge number of other services. If underneath it's server-based, it's going to include things like application service plans. It's going to include things like worker nodes for AKS clusters. Those same sizes and series will be available for me to pick so that I can make that resource available to whatever applications or workloads I run. These virtual machines are placed on a virtual network. That virtual network exists within a certain subscription and region, and I can then connect it to other virtual networks. I can connect it to other networks that are on premises via things like site-to-site VPN and ExpressRoute. Both Windows and Linux guest operating systems are supported, and I can add functionality, yes, by installing regular software. There are actually Azure extensions. These enable me to hook in via the Azure Resource Manager to provide extra help from Azure. For example, antivirus, configuration, maybe just running commands and other types of hook into that virtual machine. There are things to help me, but the key point is I have full access to everything running inside that virtual machine, so I have full responsibility for everything running inside that virtual machine. But in terms of flexibility, I should really be able to run anything I want. I can hook into all types of storage of all different performance capabilities as well. Now, there are other services like the Azure VMware solution that offer virtual machines, but these run on ESX hosts. I can live migrate from on-premises. I can manage with vCenter. There are things like Azure Batch that can use these virtual machines to run various types of job. So there are many other things that sit on VMs, but this is that fundamental building block. In this lesson, I want to explore Windows Virtual Desktop. Now, this is virtual machines and some other stuff as well. Many companies leverage remote desktops and/or application publishing. The difference is a remote desktop is I get a complete desktop experience, and then I can run various applications on it. What's projected to my device is that full desktop. With application publishing, I'm just pushing the pixels of that particular application window. If my client was, for example, a Windows device, that remote application may completely seamlessly integrate with my normal applications on my desktop. I may not even know it's remote. If it was a mobile device, then it would just have the application taking up my screen. So depending on my need, I might use a full remote desktop, or I might just want to publish a particular application. Now, WVD has this special client but it supports things like Windows clients, a web client, Mac OS, iOS, Android, and even a Microsoft Store client. What WVD does is it provides those remote desktops and published applications using Azure. Now it's using virtual machines for the actual hosts that are either publishing a desktop or applications. Now that can be Windows Client, Windows 7, Windows 10, or Windows Server based, 2012 R2 and above. But to actually provide a full remote desktop environment, it's not just the machine I connect to. I need a broker. The broker is what I actually connect to say, well, where should I go? Maybe I disconnected and it has to reconnect me back to the original machine I disconnected from. Maybe it just has to work out, well, where is their space? So I have to have a broker. So WVD provides a broker as a complete PaaS service. I don't see it. Then I'm probably on the internet. Well, I don't want to put RDP traffic over the internet. So it encapsulates it in 443 HTTPS. So that's a gateway component. That again is a fully managed component. Then there's licensing, then there's publishing of what apps and desktops are available. So all of those components are just PaaS. I don't see them. That's managed for me. So Windows Virtual Desktop is two things. It's the PaaS components that power that remote desktop, those published applications, and then the actual virtual machine sitting on my network that I actually ultimately connect to get the desktop or applications that have been made available to me. Now, one of the nice things this does is it actually supports a multi-session Windows 10. Ordinarily, I can have multi-session on a server operating system. So I can run remote desktop session host on 2012 R2, 2016, 2019, and have multiple machines connect to it, either for desktop or applications. With WVD, I get multi-session on Windows 10 Enterprise. So now I can really optimize those resources by, instead of having one person just connecting and really not doing very much, I can have 10 people connecting to the same VM to really maximize the resources it has available to it. And I really think about breaking these down into, well, I have these hosts. I put the hosts into host groups, which then have these desktops and applications made available via app groups that I assign to users. Now this integrates with Azure AD and Active Directory domain services. I need both. I need Azure AD from the management permissions plane for WVD, and then I need Active Directory domain services for the actual underlying VMs and that Windows OS running inside it for its authentication. That could be your regular AD you have on premises or something like Azure AD domain services. But if I think about, hey, I need a VDI or a session virtualization environment in the cloud, Windows Virtual Desktop is a fully managed offering with lots of built-in images with things like Office 365, or I can bring my own. In this lesson, I want to cover virtual machine scale sets. Now this is still IaaS, it's still virtual machines, but we're starting to creep up the layers a little bit, because now the Azure Fabric is actually going to take care of the deployment for me. It's going to take care of things like scaling for me, and I base it off of an image. So depending on where I get the image from, maybe I'm not so much focused on the OS, the middleware, and the runtime anymore. So what it's giving me is this large-scale deployment of virtual machines from a single gold image with configuration through various extensions. Now the access to other deployed resources are the same as for virtual machines. It is a grouping of virtual machines. It supports auto-scale based on metrics and schedules, or I can even manually just change the scale. If we jump over to a scale set, here I'm looking at a scale set that currently has one instance running inside it, but we can see under my scaling, I can actually have rules. So I have a rule based on a queue depth condition, and I have, well, when a certain queue depth hits, in this case, 5, I want to increase the count by 1. Likewise, I have a scale in, so I will decrease the number of instances when the metric is less than 2. So there's less than 2 items on a queue based on the number of instances I have. I'll decrease the count by 1. So we'll actually automatically scale this scale set. Here I'm actually looking at the queue it's monitoring. If I just actually go and add 6 messages to this queue, remember if it's 5 or more, so I'll just add, so now I've got 6 messages in the queue, that will trigger that auto scale to actually happen, and it will add an instance. Here I'm looking at the scale set, my condition was greater than 5, and now you can see it's creating. Now it's creating 2 because it creates a spare in case one fails. Whichever one completes first ends up winning. But now you can see I have that automatic scale capability. Scale sets can also be updated without taking down the entire scale set. I can think about update domains. I could update a portion of them, let's say 20%. So it would update 20% with a new image. The service is still running on the other 80%. In fact, it has a built-in auto-rolling update capability for images from the marketplace and my own custom images that are in a shared image gallery. Images have versions. So if I turn this feature on, if there is a new version of my image, it will automatically go and grab the new image and roll it out to never more than 20% at a time. So it's not going to drastically decrease the capacity of my scale set, but update it. So now I'm not having to do any patching or any manual action at all. A new version of the image is deployed. It will just start rolling it out automatically. It even has things like auto heal. If something breaks, it will detect that it's broken and fix it. And I can customize the scale behavior. The goal of a VM scale set is all of these things should be equal. There's nothing special. They're all cattle. However, maybe some are a little bit more special than others. So I can use things like instance protection to stop certain instances from maybe being scaled in. Some maybe protect even from maintenance actions. I can also control, well, when you scale, get rid of the oldest ones first or the newest ones first or other types of attribute. So we have all these capabilities. And if we jump back to that scale set just to finish, here if I hit refresh, now we can see we just have those 2 running based on our scale condition. So VM scale sets are really useful when I need to use virtual machines, but I have lots of instances based on my workload for scale and resiliency purposes, and I want to auto scale based on the actual requests coming in. And of course, typically these would sit behind an Azure load balancer, and they will automatically configure that load balancer to include them as part of the backend pool. In this lesson, I want to introduce containers, but realize the second module in this course is focused on containers. We'll go into a lot more detail. But fundamentally, the idea is I have a repository that is a store of my images. Now, those images are created from a declarative configuration that's completely prescriptive that describes the actions to perform based on some building base image. That image could be, for example, a certain operating system. It could have a certain runtime already installed. With that declarative configuration, we create our own custom app image that includes everything that application needs. Any dependency is now part of that image. We store that in a repository, and now I can take that image and deploy it anywhere. But it's completely self-sufficient. There's no worry about, well, I'm missing this dependency in this environment. I can take the image, deploy it into dev, then UAT, then production, it's guaranteed to be consistent. So I can leverage that with things like DevOps. I can continuously integrate my code, and then as part of my continuous delivery, build out that new image to actually deploy to environments. And with GitOps, well, I can pull down a configuration of deployment that would include using certain images. Now you'll notice what you're managing here, I've changed the OS, the middleware, the runtime to a slightly different
సౌండ్ మూవీ సినిమా చూడాలా
ఏ సినిమా చూడాలా
మూవీ సినిమా
కొద్దిగా తగ్గి
లే లేసే నీకేం క్లాస్ కావాలో లే 2 రోజులు ఫ్రీగా ఇందు వద్దా ఇయర్ ఫోన్స్ పెట్టుకుని జోలు పెట్టుకోమోనా